Okay, guys, I'm gonna talk about a tech stack to build a customizable chat app for iOS. Please feel free to interrupt me and ask if you have questions during the presentation. This is the agenda of the presentation. I'm gonna give you a brief intro on the whole structure, some motivation on why we decided on that stack, and then explain a bit on the main items of this stack, and then a brief conclusion and the references. Okay. I don't know if everyone has this idea in mind, but a chat app, it basically wraps most of the functionalities, if not all, provided by a smartphone. So if you think about messages, they use push notifications. In this case, we used one signal. Media messages, they require access from your camera and your microphone, and you need AV player to play videos and photo library to present them. Location messages use car location and maps to present the results. If you want to persist the messages, you're going to use either car data in this case, or Realm, or some other tool. If you want to back up the messages, you're going to use CloudKit, or you're going to have to integrate with your own server. Save media, you need the Photos framework. To reach the contacts of your devices, you'll need the Contacts framework, and it goes on. Later on, I'm gonna focus on the technologies for specifically the chat services. But if you take a quick look on Google, and you ask for chat services for mobile, you're gonna find several solutions.
Sorry,
some of them.
I don't know how to help with that yet.
Some of them are paid, and some of them are open source. You can find Sandbird, QuickBlocks that Nathan used on another app, Layer, and it goes on. And you also have open source ones, Chat SDK, which is backed up by Firebase and Google. Or Actor, which is a whole platform. You have the server side, the iOS side, the Android. You have everything on a GitHub repo, and it goes on. So the motivation on why we decided on the stack, I'll later on explain which stack we decided. The main reason was customization. On this project specifically, it was required for us to send scheduled messages, and that's not something that usual chat services provide. So everything else, most of those out of box solution, they will help you. They will do basically everything you need. But we needed these scheduled messages, so we need to customize the server side. We need to customize the relationship between the client and the server. There's also the price, because our solution was open source, and scalability. Well, we decided the infrastructure, so we basically scale the way we want. The tech stack we chose was for the XMPP server was Mongoose IM, which is made in Erlang. XMPP client in iOS was the XMPP framework. For the chat UI, we used JSQ messages view controller, and I want to talk about this later on, but that's something I thought would be nice to bring it up on the data source performance to fetch the data with fetch results controller. So first, the Mongoose IM. Sorry, I don't know that much on the server side. It was implemented by someone else. And if you guys want to talk to Vinny, he's the one that gave maintenance to this, so it's probably the one you guys should talk to. The XMPP framework. Well, XMPP framework, it just provides a core implementation for the XMPP standard, which is a widely used protocol for chat messages. It stands for Extensible Messaging and Presence Protocol. It's used by several solutions, from WhatsApp to, I don't know, maybe, I don't know in numbers how much, but a lot of them use this protocol. It is massively parallel and thread safe. It has a modular architecture with multiple extensions. I'll give a brief example later on how one of these extensions works, but rosters are related to contacts. The message, XMPP message, is related to messaging. The archiving to store messages. Last activity is the one responsible for you to present the last time the user was online. Was that last seen, what you usually see on chat apps. The XMPP blocking for you to block users you don't want to have a conversation with. MUC Lite, which is related to group conversations, and it goes on. There's like 300, more than 300 extensions for that. And one thing that it's really nice to see is that they rely on multicast delegate, which was something that I've never seen before. It was really nice to see how that works. I'll explain a bit later on that. So just to explain a bit how XMPP works, basically they communicate with stanzas. So for everything, for every action, every message you send, every presence you send to someone, they use stanzas. So this is an example of sending a message. It's basically an XML message with tags like message and body from some user to another one. So if you want to add here a tag for message marker, let's say for, I just want to tell them that I saw the message. So you see that the displayed message tick on the chat UI and all that. You can add ID for the message so you can keep track of it. You can add everything. All those all those extensions up there, they simply add a different tag here and they keep track of it. So for replying a message, it's kind of the same idea. So here's an example of how one of those extension works. This is the one related to the XMPP roster. So I'm not gonna go through all of those extensions because I think it's not that interesting. But if you want to see just one example on how that's done, this is a good one. So basically, I have this client manager, which is a singleton throughout the app, and it's gonna handle all the relationship between the client and the server. And then you just have to set up that extension, like set up roster. You just go define some criteria here, and you add it as a delegate. So this is the multicast delegate I mentioned before. So basically what you do here is you add this class as a delegate in a delegate array. So for everything that the server sends and the XMPP roster gets as message, this class will see and will be able to handle it. And it can handle it through implementing the roster delegate. So for example, if you receive a present subscription, like someone wants to talk to you, and they send this first message, you receive that right here. Just by adding it as a delegate, you can handle it in this method. I didn't add the implementation of the method, but that's okay. Just some other examples, like roster did begin populating, did end populating. If you want to get a list of all the contacts you have and you want to talk and you have for your user, this is where you'll get all these contacts. So that's one of the examples. For every single extension that I listed before, like here, roster, archiving, last activity, blocking, for each one of them, you have separate setup like that and a separate delegate implementation. So it just goes on like this. About the GSQ messages view controller, which was the solution for the UI, it is very easily customizable, very easily extensible, well documented. There's a large community to help if you want to do anything, customize anything. There's a lot of people that already tried it, and you can get these examples. It has more than 10K stars on GitHub, so just go there. There's someone that will be able to help you there. They even have their own tag on Stack Overflow. So you go GSQ messages view controller, and there's tons of questions answered there. This is an example of how it's done. This is the default UI that they provide. They provide a simple collection view controller with default parameters for everything, for avatar size, for bubble images, the font size, position, margin, images, image messages, for everything. Basically what you do is you customize it, telling them, oh, I want the padding different. I want to change the background image. I want to change the way audio message looks. So you practically customize everything. That is the result of the customization. It's like that. And there's this is not actually they're not a stack that tech stack. The fetch results controller is more like a way to solve this data source performance issue. This was one of the biggest issues that I found while implementing the app. It's related to fetching the data and adding to the chat UI. So basically what we do usually on the projects we have is we get the data, we copy it into an array, and then from this array on we just we bind it to the data source. Like the amount of data in the array is the size of your table view and all that. But that would take, for let's say 50 items, the screen would take more than a minute to load. So that is unacceptable. And this was the best way I found to solve that issue. So by using NS fetched results controller, I mean it's an efficient way to load hundreds or thousands of items into a table view. It has a seamless integration between core data and table view data source or collection view data source. I'm going to show you later code on just to show how they integrate so well. And one of the other issues I had to solve for free was infinite scroll. So infinite scroll, you don't need to pull to refresh or anything like that. It's for free in the solution. So just to show how it works, this is how the fetch results controller delegate. These are all the methods you have to implement, which is basically will change content, did change content, or did change section and did change object at index path. So if you think about how the table view works, it's the same basically. So on the will change content and did change content, you just add the table view begin updates and end updates. It's done. Just to show how it goes. The change section has these options: insert, delete, move, and update. So basically, for each method, you just add the equivalent method for table view. So table view insert sections or table view delete sections, and the same goes for rows. So insert rows and delete rows or move rows. So they have methods that connect seamlessly. So with this, you can load thousands of items into a screen because it's gonna fault the items and use and present only the ones that are on the screen, like 5 or 6. And then as you scroll, it will keep fetching data from the core data, and it's gonna work. This is just how to set up on the table view. You just add a fetch results controller, and on the data source of the table view, you just tell them that the fetch results controller number of sections and then the number of objects for that section, and then you're done. That's all you have to do. Some conclusions. I'd say XMPP framework is a great tool. Just it's very time consuming. So just use it if you need a customized behavior. If you don't, go for the out of the box solutions. There's those open source over there, and they're good solutions as well. And some other tips on this project: make sure you know your tools. Study them before you just use them in the project. It will save you a lot of time. And also, careful when binding the behavior of a framework with your app. For a long time, I was trying to connect the framework with the app, and just when I added an interface to make them work independently, it started working fine. So that's one of the tips I got from the project. Some references, like there's tons of open source chat apps on GitHub, a lot of libs and frameworks also. If you want documentation on Mongoose, XMPP framework, and all those, they're all on GitHub. And this is documentation from Apple on how to integrate the table view and the car data.